Welcome back. In this video, we are supposed to take the last question of the exercise 13.1 and we will continue with the second exercise then. Question number 8. What the question says, from a solid cylinder, right, whose height is 2.4 centimeter. The question is about the cylinder. Let us make the cylinder first. This is the cylinder whose height is 2.4 centimeter. So simple, height is equal to 2.4 centimeter. This is height of cylinder and diameter is equal to 1.4 centimeter. Phi is equal to 1.4 centimeter, right? Then, and the same diameter is a conical cavity of the same height. That means it's dug up like this. A material is removed like this conical shape, right, from the top of the same height. That means the conical point will be at this point here at the center. Find the total surface area of the remaining solid to the nearest centimeter square. So simply, what will we write? Here, diameter of cylinder is equal to diameter of cone. Right? It's simple. The diameter of cylinder is equal to diameter of the cone. That diameter is equivalent to 1.4 centimeter. And R simply, or we can say, which implies radius of cylinder is equal to radius of what? Radius of cone. That simple, small r is denoted is equivalent to 1.4 by 2, that is 0.7. That is 0.7 centimeter. Then what? We are given by its h. That is the height of cylinder. And that height will be in turn equivalent to what? Height of the cone. Now, height of cylinder is equal to height of cone. That's equivalent to 2.4 centimeter. That's equivalent to 2.4 centimeter. Now, we will calculate, this is L, this is the slant height of the cone, and this is H, H is equivalent to 2.4 centimeter, and R, R is equal to 0.7 centimeter, right? We are supposed to calculate the L. Why? Because to what? Determine the curved surface area of the cone. So L square, we will write, we know that L square is equal to R square plus H square by using hypotenuse theorem. That's L is equal to under root of R square plus H square. What is the value of R? R is equivalent to 0.7 whole square plus what is the value of H? It will be 2.4 centimeter square. So calculate this, the value is, it's a 0.49. 0.49 plus 2.4, that's equivalent to 5.76, and that comes equal to 6.25. Under root of 6.25, that is equivalent to 2.5 centimeter. That means the slant height is equal to 2.5 centimeter, right? So H we know, H of the cylinder we know, R of the cylinder we know, L of the cone we know, R of the cone we know. So we are done. So we will now use the formula. So total surface area of this block will be equivalent to curved surface area of cone, that is a C dot S dot A of cone, plus what? Curved surface area of cylinder. That means C dot S dot A of cylinder. And what else? That's a base. That's a base circle, right? And at the top, it's empty. So we will not take that part, we will take only this part. It will be plus what? Area of base of cylinder. So curved surface area of cone, we know that. That's equivalent to pi RL, right? Pi RL plus curved surface of a cylinder, that is 2 pi RH. And the area of what? Base cylinder, that is a pi R square. Clear? That's a pi R square. So we can take pi R here, pi R here, pi R here. Pi R, it will be L, pi R 2H, pi R and R. Now put the value and get the answer. What is the value of pi? 22/7. What is the value of R? R is here 0.7. Then L. So L, we calculated. What is the value of L? L we calculated. It's a 2.5 plus 2 into H. What is H? It's a 2.4 plus R. What's the value of R? It's a 0.7. So simply what we are supposed to do? We are supposed to do the simple mathematics and we will get the answer. So simply I will write the answer here. The answer is 17.6 centimeter square and the nearest to the 17.6 is, that is 18 centimeter square. Done. This is all about the exercise 13.1. We have concluded the exercise 13.1. And now let us move on to the exercise, that is the 13.2, and exercise 13.2 is totally based on to find the volumes. Exercise 13.1 was based on the surface areas and exercise 13.2 is based on what? Volumes. Now exercise 13.2. Question number 1. What is the question? I will read here. Question is like this. A solid is in the shape of a cone standing on a hemisphere with both their radii being equal to 1 centimeter. That means it's like this. Hemisphere is surmounted by a cone and their radii is equal to 1 centimeter. R is equal to 1 centimeter. Clear? Then find the volume of a solid in terms of pi. We have to find the volume of this in terms of pi. What is the height? What is the height? H is equal to, and the radii being equal to 1 centimeter, and height of the cone is equal to its radius. That means height of the cone is equal to R is equal to 1 centimeter. From here to here, it's again R. R is equal to 1 centimeter and height is equal to what? It's a 1 centimeter. So simple. Here, radius of cone is equal to radius of hemisphere. That's equivalent to small r is equal to 1 centimeter. Right? Also, height of cone. Height of cone is equal to, that's the h, but it question says height of cone is equal to the radius of the what? Cone, and that's equivalent to 1. That's equal to h equal to r and r equal to 1, which in turn means h is equal to 1 centimeter. Clear? So what we are supposed to find? We are supposed to find the volume of this object. Object composed two things. One is the cone and second is hemisphere. We write volume, therefore volume of this what? Solid is equal to volume of cone plus volume of hemisphere. we must remember the formulas. Volume of cone, that's equal to 1 by 3 pi r square h plus volume of hemisphere, that's 2 by 3 pi r cube, right? Yes, 1 by 3 pi r square h and 2 by 3 pi r cube. So 1 by 3 and pi plus what? R square, r square here, it will be h here plus 2 times r. Clear? So r is 1 by 3, pi we are not supposed to substitute the value because we have to find the answer in term of pi. It's pi. What is the r? It's a 1 square. What is the h? It's 1. What is the r? It's 1. So it will be pi into 1 square, that is a pi, divided by 3, multiplied by 2 into 1, that's 1, 1, 2 plus 1, that's a 3, that's 3, 3 got cancelled, it will be pi centimeter cube. The answer is the volume of this solid, which contains what? A cone and a hemisphere, and a hemisphere is surmounted by a cone with the dimensions h is equals to r, and that too it's equivalent to 1 centimeter, and we got the answer of the volume of this solid, that's equivalent to pi centimeter cube. Am I clear? So let's move on to the next question of this exercise. Next question, that's question number 2. Question number 2, exercise 13.2. Rachel, an engineering student, was asked to make a model shaped like a cylinder with 2 cones attached at its 2 ends by using a thin aluminum sheet. So we got it. This will look like this. This is a cylindrical part and 2 cones attached to it is what? Ends. So simply it will look like this. But here is a condition. Condition is simple condition that it must be coaxial. It must be coaxial. Sir, what is a coaxial? Coaxial means if you have a solid structure composed of more than 1 bodies, then the axis of every body must pass through its centers. The center of the cone is this, the center of the cylinder is this, the center of the cone is this, and there should be one what? Line of symmetry. Okay? From this part to this part, this will be definitely, we can call it height or we can call it length of what? Of a cylindrical part. So let it be small l, and then it will be h, height of the cone. This again h, height of the cone. What is the total length of what? This model made by an engineering student whose name is Rachel. So total height, let us denote by that capital H. That is simply small l plus twice h, as simple as it is. Now, the diameter of a model is 3 centimeter. The diameter, it's r here, it's r here. So phi is denoted for diameter. Diameter is given, that's equal to what? 3 centimeter. It's 3 centimeter. So simple, the r will be equivalent to 1.5 centimeter. And its length, whose length? The length of the model, that's a capital H, length of the model. Not the length of the cylinder, not the length of what? A conical part, but it says the length of what? Model. That's a 12 centimeter. So we can say H, capital H is equal to 12 centimeter. Clear? Find the volume of the ear contained in the what? Model. So simple, we have to calculate what? We have to calculate the volume of this object. The object is in the shape of what? A cylindrical part and the 2 cones at 2 ends. Simply, we will find the volume of this cone, we will find the volume of this cone, and we will find the volume of this cylindrical part, and we will sum up the 3, and that will be our answer. So simple. So we will first of all calculate the L, that is this length of what? Cylindrical part, and then we will calculate the what? Its h. Clear? Anything else is given? Yes, height of each cone is given. That is a 2 centimeter. It is given. It's 2 centimeter. So simply small h is also 2 centimeter. So we will calculate the L. We write here diameter of cone is equal to diameter of cylinder, or we can say simply, which implies radius of cone is equal to radius of what? Cylinder. That's small r is equal to what? That's 1.5 centimeter. Right? Also, capital H, that's the total height of the model, is equal to small l, that's the height of the cylindrical part, plus height of what? One cone, height of second cone. This is given, that's a 12 centimeter. L, height of the cone, it is also given, that's 2 centimeter. That's 2 plus 2, 4. That is 12 is equal to L plus 4. That's 12 minus 4 is equal to L, or we can say L is equal to 8. So we can say here L is equal to 8 centimeter. That means the height of the cylindrical part is 8 centimeter, and the height of what? Cone part, it's a 2 centimeter, and diameter is same everywhere. That the diameter is equal to 3 centimeter, and the radius we got, that's a 1.5 centimeter. We have to find the volume now. So simple, we use the formulas. So we will write, therefore, volume of air contained by model is equal to, simple, volume of cylindric part, we can write volume of cylinder, plus twice the volume of cone. So volume of cylinder, we know that. What is that? What is that? That's a forget it, that's a pi r square h. That pi r square h plus volume of cone, that is 1 by 3 pi r square h. That's 1 by 3 pi r square. That's the volume of the cone, and the volume of cylinder is equal to pi r square h. So it will be pi r square h. This is a cylindrical part. So we will not write here h, we will write here L. It's small h, it's small h. So it's pi r square L plus 2 by 3 pi r square h. R and R is same. So what we will do? We will do one thing, pi and r square. Just do one thing, pi r square, it is L plus 2 by 3 h. Clear? So now what we are supposed to do? We are supposed to only substitute the values. We will substitute the value. That's what? 22 by 7. What is the R? That's 1.5 multiplied by 1.5. What is the L? What is the L? L is equal to 8 plus 2 by 3 into H. What is the H? That's 2. So simple mathematics. It's 22 into multiplied by 1.5 multiplied by 1.5 whole divided by 7. This is 2 by 3 multiplied by 2. This is 8. So solve this problem. It's very easy, and we will get the answer. That's equivalent to 66 centimeter cube. This is the answer. That means 66 centimeter cube of air is contained in this model, which was what? Which was built by who? An engineering student named Rachel. And the model is in the shape like this. This is a cylindrical part and 2 cones. Okay? And the next video I will make, that will be the next questions of this exercise. Till then, Allah Hafiz, take care, stay home, stay safe.